Right at the beginning of the course, let me answer a question that many students have in their mind. The question is, how is static electricity different from electric current? Or we can say it like this, what is the difference between static electricity and electric current? Now everyone knows about electric current because they have been using it from their childhood. So this question comes naturally to them, what is the difference that electric current and static electricity? So let me answer that question in this lesson. See, in electric current, there is a flow of electric charge. So in electric current, what happens? Some electric charges flows from one point to another point. So there is a flow of electric charges. Okay. But in static electricity, the charges do not move. They stay at the same place. So electric charges remain at rest in static electricity. See, the charges remain at rest, but they exert their influence in the space around them. So say, if we have a charge, in static electricity, this charge will remain at rest. It will not move. But it exerts an influence in the space around it. Okay. This influence is experienced by other charges placed in that space. So what happens if in this space, if we place another charge, this charge will experience a force. It will experience the influence of this particular charge. Okay. So that's why what we say is that in electrostatics, though the charge does not move, it remains at rest, but it exerts an influence in the space surrounding it. Okay. In electrostatics, we study about this influence exerted by static charges. Okay. Now please note that in this lesson, I am using the common English word influence because we haven't learned any technical term or jargon of electrostatics. Later, I'll stop using this term influence, and instead of that, I'll be using technical terms of electrostatics like electric field intensity, electric potential, terms like that. Okay, but to make it simpler for you to understand at this stage, I'm using the common English word influence. Influence of a charge in the space around it. Okay? Now in this word electrostatics, the electro part comes from electric and the statics comes from stationary. Simple. Now let's learn how we can generate static charges. Okay. See, centuries ago, people observed that if we rub a glass rod with silk cloth, the glass rod becomes charged. Now, the charged glass rod can attract small bits of paper. This they observed centuries back. Okay. Say, if we have a glass rod and we rub this end of the glass rod with a silk cloth, then what will happen is this part of the glass rod will become positively charged. That part where we rubbed it with the silk cloth. Okay. Now understand the point that only this portion will become charged. These charges will not flow to the other part of the glass rod. Why? Because glass is an insulator. Okay, we all know that electric charges cannot flow through an insulator. So these charges will remain here. They will not flow to this part of the glass rod. That means these charges will be static charges. They will be at rest. This is how we can generate static charges. Clear? Okay. Now consider another situation. Say we take an iron rod and we hold it with our hand. Okay. Now we want to put some charge on this end of the iron rod. So say I take an electric cell, a battery, and connect the positive terminal of the battery to this end of the rod. Now what will happen? Charge from this cell will flow to this end of the iron rod, and since iron rod is a conductor, this charge will flow through the conductor, through the hand of the person, and it will flow to the ground. The charge will go to the ground. Okay. As long as we keep it connected, charge will keep on flowing through the rod, through our body to the earth. Okay. Now say we disconnect this battery. Will there be any charge on the rod? No. Why? Because the charge will flow to the ground through our body. Clear? Okay. Now let's take another case. Iron rod with insulating handle. So this is the iron rod, this is the insulating handle. So now there is no connection between the iron rod and our body. Clear? Now if we connect a cell like before, the positive terminal is connected to this end of the iron rod. Positive charges will flow to the iron rod, and this positive charge will flow to this end of the iron rod. Now it cannot go further because this is an insulating material. So the positive charges will get distributed over the whole iron rod. Now if we disconnect the battery, we'll see that these positive charges will remain on the iron rod, because now these charges have nowhere to go. They cannot flow through the insulating material to the ground, so they will remain on this iron rod. And we know that iron rod is a conductor, so this is the way we can put some static charge on a conductor. We must use an insulating handle or an insulating stand to hold this conductor. Clear? So that's all in this lesson. Let's go to the next lesson now.